Welcome back to my channel Techno Namaste. I'm Dr. A. Navanita, Assistant Professor in EC Department, Mahatma Gandhi Institute of Technology. So today I'm going to discuss an instruction, arithmetic instruction of 8086. That is nothing but add instruction. So already we have discussed in the previous video what is an instruction and directive, that you can go through that. Just I will give the overview of instruction. Instruction is nothing but a command given by the programmer to the CPU to do certain operation. That CPU which we are taking is nothing but 8086. Okay. So here whenever any CPU is manufactured by any company like Intel, TSMC, Motorola, any company, that those companies, once they manufacture a CPU, they will develop the instruction set also. So here this instruction set is going to contain a group of instructions. That group of instructions will be telling by the programmer to the CPU what operation it is going to do. So add is one instruction which comes under your arithmetic instruction. So this is a this instructions will be written with the English keyword along with whatever the keyword you are using, that is called as the opcode. Opcode on which it is going to work is said to be the operand. So it is there is a source operand, destination operand. Rightmost one is said to be the source operand and leftmost is said to be the destination operand. Opcode plus operands will give rise to instruction. Okay. So here whenever you write the add instruction, you can use source operand and destination operand as a register, or source operand as a data and a register, destination operand, and a source operand a data in the memory location. Once a bracket a number is written or register is present, means that represent a data in the memory location or a register. One is nothing but a register and a data present in the memory location. But one thing you have to remember, that the source operand and destination operand, you should not take the data present in the memory location. This is not accepted. All the four can be accepted. So instead of here, whatever the registers which you are taking, all the registers in which you make use an instruction which is used in the assembly level language programming, all these instructions are present in 8086. Think we have written an instruction add AL comma BL. BL and AL are registers, 8-bit registers present in 8086. Once this instruction is given by the programmer for the 8086 CPU, it will execute in the ALU. After the execution, what it will do, during the execution what it will do, it will add the content of AL and BL register, and this AL and BL register, after adding, it is going to place in the AL. So think AL is containing 2 hex digit number 3E. H represents hexadecimal number we are going to take in the program. Programmer can give the numbers in octal, decimal, hexadecimal or binary. Here we are giving in a hexadecimal. BL is going to represent a 2-digit hex number 5FH. So already you know that 10 is represented as A in hexadecimal, 11 is represented as B, 12 is going to represent as C, 13 is going to represent as D, 14 is represented as E, 15 is going to represent F. So here in this one we have to add a digit wise digit. E plus F, that is E is 14, F is 15. If you add this, what you are going to get here? 29. So here this 29, whatever you are getting, it is more than your 16. So if it is more than 16, we have to divide with the, if it is more than 16, you have to divide that number, whatever the more than 16 is there, with 16. So if you divide with 16, 1 is 16 and 29 minus 16 quotient, remainder whatever you get is nothing but 13. 13 in the hexadecimal is nothing but D. So you can write as 1D, quotient remainder. So whatever the quotient remainder you got, D you are going to write here, and whatever the quotient is there, it will be sent to the next digit. 5 plus 3, 8, 8 plus 1, 9, 9D. So you are going to get as 9D here. Okay, so here in this one, whatever the 90 you got, you are done with theoretical. Same value if you use in any system. Similarly, if you use in any software using DOSBox or MASM, then in that one you have to see in the register AX, which is going to contain AL. That AL it is going to contain what value? 9D. So 9D should be present in AL and AH will be having some garbage value. So this is how your add instruction is going to work. Instead of add, if you have add C, the ADC, if you write, this represents add with carry. So here also the instruction you are going to use ADC, ADC, okay. Here also ADC, here also ADC. So here operands also you can make use as of that add instruction to register contain one user data and register, one memory location data and register, one register and data in memory location. Both memory location you should not use. So whenever you make use of instead of add ADC, what it will do, the content of AL and BL will be added with which one, with the carry value. Think the carry flip-flop is holding 1, that is carry flag. So after addition what you got here, AL is holding this, BL is holding this. After addition you got 90, isn't it? So with this one carry, what is the value here? 1. So that you are going to add here to the resulted one as a 0, 1. D plus 1, D means what? 13. 1 if you add, what you are going to get for 13, 1, 14. 14 is nothing but what? E. So here you are going to get 9EH. Whatever the 9EH you got in the theoretical way, that it should be loaded in the AL. That you can verify in the system using these software tools by writing the program using ADC. And in the AL register, what you are going to have now, earlier you had 9D, now you are going to have what? 9E. That you can verify in the system. So I think you have given some idea of add instruction. If you like my video, subscribe it, like it and place some comments so that I can improve my videos. Thank you once again.